In today's lesson, we'll be talking about relations and functions. So first, to define a relation is a set of ordered pairs. So we talked about ordered pairs in our last lesson, any location on the graph, x, y. So any set of those together, put together, is going to be called a relation. Now, the set of all first elements, or like the x values, the x part of the x, y, in a relation is called the domain. And the set of all second elements, or y values, in the relation is called the range. So let's show you a relation. Let's say the following students, April, Bob, Carlos, Dion, and Ava, all have certain colored shirts. We'll say April is associated with red shirt, Bob has a blue shirt, Carlos has a green shirt, Dion has a black shirt, and Ava is also wearing a blue shirt. So the domain of this relation is the set of all first components. Now, normally we use this x, y, but in this case, maybe that they're not x's, they're just students. But nonetheless, it's the first component, so the domain of this relation is April, Bob, Carlos, Dion, and Ava. Now I put those little braces around the domain because that's set notation. So if you are trying to draw those, it's just like an S and then like a backwards S, okay? Like backwards S and an S. That's how you draw the those braces. Or if you just do squigglies, I'll understand what you're saying too. So the range of this relation is red, blue, green, black, and blue. But I don't have to write blue again because I already wrote it down. So the domain is just the set of all the first components, the range is the set of all second components. Now, there's a special kind of relation called a function. Now, a function is a relation with a special property where each element in the domain corresponds to exactly one element in the range. So let's think about our student shirt color relation. Okay, so we have April in this is the domain on this side, and this is the range on this side. So we have April and Bob, and Carlos, and Dion, and Ava. And they have certain colored shirts, red, blue, green, and black. Now this is one other way of writing a relation. You put all the domains in one circle, you put all the ranges in the other, and then you make a relationship with arrows. So April is the one that was wearing the red shirt. Bob was wearing the blue shirt. Carlos was wearing the green shirt. Dion was wearing the black shirt. And Ava was wearing the blue shirt, so we have a second arrow going there. So let's look at the definition of a function. A function is a relation. Well, this is definitely a relation of the student shirt color, but is every element in the domain corresponding to exactly one element in the range? So April only has one shirt, that's red. Bob only has one shirt, that's blue. Carlos has one shirt, and that's green. Dion has one shirt that's black, and Ava has one shirt that is blue. So this definitely is a function. So I'm going to say yes, it is a function. Now, let me just make up another one. So I will make up another domain and another range, and then you'll test the same question. So I'm just going to put some values here. So 2 is being mapped to 1, 4 is being mapped to 3, 6 is being mapped to 5, and then 6 is being mapped to 7. So if I was to write all of these out, I would get the points 2, 1, 4, 3, 6, 5, and 6, 7. So those are my points. This mapping and this are the same, just two different ways of representing a relation. So my question is this relation a function? Yes or no? That's my question. Well, the answer here is no. And the reason it's no is because this 6 is corresponding to both the 5 and the 7. That problem right there is not allowed in a function. Remember, the definition of a function is that every element in the domain, every element in the first set, can correspond to exactly 1 in the range. Well, this 6 is trying to be mapped to the 5 and trying to be mapped to the 7 at the same time. Now, one silly little story that I tell about this to determine if things are a function or not is I use the domain as the set of all guys, and the range is the set of all girls, or vice versa. It can really be either way. So the set of all domains can only date one person in the range. So let's go back to this relation. 2 is trying to date 1. This boy 2 is trying to date this girl 1. That seems like an okay thing to do. That is a function, if we just had that one point. 4 is trying to date 3. Okay, that's fine. Now 6 here is trying to date 5, which would seem okay, but he's also trying to date 7, which is not okay. 6 is trying to date 5 and 7 at the same time. That is not a function, is it? That is not a functional relationship going on whatsoever. 6 can only be dating one value in the range at any one point. Okay, so here's the catch though. Even though the domains have to be on their best behavior, meaning every element in the domain can only be mapped or dating one element in the range, it is not the case for the ranges. The ranges are allowed to have date as many people as they want. Okay, the ranges don't have to be on their best behavior. For example, in our first one, if we have April is dating red, Bob is dating blue, Carlos is dating green, Dion is dating black, and Ava is dating blue, that means blue is 2-timing. But that's okay in this case. So it is still, yes, a function because blue is in the range, and the range doesn't have to be on its best behavior. Okay, it's only the domain that has to be on its best behavior being mapped to 1. So in order to be a function, the domain cannot repeat. Now, functions can be expressed in several ways. We are going to express functions as sets, as graphs, and as equations. Now, functions as sets can look at a couple different ways. They can look like t-charts, like 1, 2. So this is the points 1, 4, 2, 5, and 3, 6. Here's two different ways of writing it out. I could say the set of the points and list the ordered pairs. I could list the ordered pairs in a t-chart, or I can list the ordered pairs in a graphical display with my mapping. All three of these are functions as sets, which are individual points. This only works for a finite number of ordered pairs. If it's an infinite amount of ordered pairs, you would probably not want to write them all down, as it would take you forever. Now, functions as graphs could look like just values, some discrete points. If you took your function and there's an infinite amount of points, they may look like a line. All these points along here are so dense that they might look like a line, or they might look like a quadratic parabola. There's a lot of different ways these graphs could look. And then the last one is functions as equations. So some functions would be like a linear function, y equals 3x plus 2, or maybe a quadratic function like this one. Now this y value, we are going to learn in this lesson a new notation called function notation that is going to replace that value of y with a different function. So those are the three ways that we're going to be talking about functions today. So let's first talk about functions as sets. So I want you to determine if the following relations are functions and then find its domain and the range. My domain is just the set of all x values. So because this is just some discrete values, I'm going to use the set notation, those little braces. You can use squigglies if it's hard for you to draw these braces. The range is just the y values. Eight, 4, 0, and -4. And then to answer the question, is this relation a function? I have to decide, does any of the x, the red x values, are they ever mapped to more than one y value? Well, since the red x values don't repeat at all, you know that two x values can't be going to two different y values. All right, let's do this again. 3, 3, 8, and 1. So my domain is 3, 3, but I'm not going to write it again. 8 and 1. My range is my y values. 4, 5, 9, and 0. But notice, is this a function, yes or no? Well, the red value 3 is being mapped to 4, but then later it's being mapped to 5. Okay, so this red 3 is trying to date both 4 and 5 at the same time? I don't think so. That is not a function. Alright, so here's two more examples. This is the t-chart. So my domain is going to be all of the values in the x column. So 1, 2, 3, 4. None of those repeat, which is a good indicator that it's going to be a function. My range are my y values, 5, 6, 6, and 7. Okay, now this 6 repeats, huh? So 2 is being mapped to 6 and 3 is being mapped to 6. Is that a function? Well, sure it is. The reason it is because y's don't have to be on their best behavior. The only thing that matters is that the red x's have to be only mapped to one individual y. So in fact, 2 is trying to date 6, 3 is trying to date 6, but that's okay, as long as my x values are only trying to date one person at a time. Now the blue values, the y values, they can be receiving as many offers for dates as possible. It doesn't really matter to the y's. The y's can accept anything they want to. It's the x's that can only be mapped to one value in the y. Alright, how about this one? My domain is the one on the left always, and the range is the one on the right. So my domain is going to be 5, 4, and 3. My range, I should do that in blue, is -8, 6, and -3. So is this a function, yes or no? Well, 5 is trying to date -8, that's okay. 4 is trying to date 6, that's okay. 3 is also trying to date 6, that part's okay, but it's this part that's not okay. This x value 3 is trying to be mapped to two different y values. That is not okay. So this is no, not a function.